Everything in this series so far has run on a single node, and for a lot of buildings that is genuinely the whole answer. You add a second one for reasons that have nothing to do with running out of room. To sit a node close to the equipment it talks to keep the site running when one of them goes down, or to give a noisy workload its own machine. So let us look at what actually happens when there is more than one. Each node keeps a list of its peers, and that list is just entities in the same database as everything else. Open one and it holds a host and a port, and a status saying whether the connection is up right now. This deployment runs 2 of the 3, and the list says so plainly rather than hiding it. Which is the part worth noticing. You never typed an address into a device or a connection string into a file. Nodes find each other and hold the connection open, and what you are reading here is the result. Now the part that makes a cluster worth having. Walk into the other node into its own list of services and open one of them. This service is not running here. It runs on the second node on its own kernel, and it is writing its own state as it goes. And yet you are reading it from a screen connected to the first node. Look at who last touched these fields, the service itself, not the kernel you are logged into. Nothing was exported and nothing was copied across. There is one store and both nodes are in it. That is what synchronizes the entity tree, the values, the schemas, and the automations you built. What each node keeps to itself is its own copy on disk and its own service logs, which is exactly what you want when you are trying to work out what one machine was doing. The 2 nodes are not clones either. Look at what each one is actually carrying. This node runs the Modbus service talking to the plant, and the mail service and the configuration manager. The second one does not. Work sits where you put it, and the shared store is what keeps the 2 views of the building identical. Which leaves one obvious question. If a node can go down and the work is spread across them, what happens to the job it was doing? That is the next one.